Okay, now let's proceed to another classification of bearings. According to type of friction ay ang rolling bearing natin. Okay, next. There you go. Classification of rolling element bearings. So first we have the ball bearings. A ball bearing is a type of rolling element bearing that uses balls to maintain the separation between the bearing races. So from the word itself, ball, yung bearing niya is bola, bilog lang, na naka-contain sa isang casing sa isang house. Then, dun, nakaipit siya dun, nakasandwich siya dun. And yun yung nagpapadulas sa, yun yung gumugulong sa kanya sa loob. Ball bearing. Now, we have the roller bearing, are similar to ball bearing in that they are designed to carry a load while minimizing friction. Similar daw, no? So, Ah, in if yung ball bearing is bilog, ang roller bearing natin naman is para siyang cylindrical shape like this one, no? Ito yung nakaipit siya dun sa case yan, tapos ito yung nagro-roll yan. Yun ang roller bearing. And a needle bearing is also similar to a roller bearing. Pero yung ganito nating rollers natin is parang needle-like, mas pahaba siya. More kesa sa cylinder shape, mas pahaba siya. Halimbawa yun, na maliliit, nagro-roll din. Needle bearing, by definition, needle roller bearing is a special type of roller bearing which uses long, thin, cylindrical rollers resembling needles. Yan, kaya tinawag siyang needle bearing. But similar din siya sa roller bearing. Yun nga lang, para lang siyang needles na pinanipis pa yung cylinder shape na. Next. Another, we have a classification of bearings according to load application. So, we have the radial bearings or yung typical nating bearing or journal bearings, kung tawagin. We have the thrust bearing and the guide bearings. Okay, by definition, supports radial load. Sa thrust naman, carries a load collinear to the axis. And guide bearing primarily guides the motion of a machine member without specific regards to the direction of load application. So, paano ba mas madaling maintindihan yan? Let me demonstrate. Imagine ito yung ating bearing. Yan, napakalaking bearing na to. And we have a shaft. Yan, ito yung papel na to. Yan. Nakapasok yung shaft natin sa loob ng bearing. So, radial bearing, sabi, supports radial load. In layman's term or simple definition, yung load natin is perpendicular sa ating shaft. Pababa siya or yan, perpendicular yan. Perpendicular sa bearing natin at sa ating shaft. Thrust bearing carries a load collinear to the axis. Yan, papunta dito. Papunta ang ating thrust bearing. Okay? Yan. And a guide bearing is a bearing that has housing. Hindi lang siya basta bilog. Ito yung ginagamit sa ibang industries, sa shaker machine, if you're familiar with that. Para maiwasan ang misalignment ng machine natin. Hindi lang siya yung basta bearing na bilog. Ito siya yung para siyang may housing, and sa loob ng housing is may bearing. And rigid siya para dito lang napaano yung ating shaft or journal. Okay? So, next. Fun fact, icebreaker natin, the world's smallest bearing. So, kung ang bearings is, kung tatanungin maliit na nga, and syempre meron din gumagawa na malalaki, in Minerva has succeeded in the commercialization of ultra-small ball bearings that are 1.5 mm in outer diameter na yun, ha? And 0.65 mm in thickness, making them the smallest bearing in the world. These ball bearings have the same pressed steel ball bearing cage structure as normal miniature ball bearings. So katulad lang siya ng ating ball bearings or journal bearings na pinaliit lang. So makita dito yung ating specifications itong napakaliit na bearing na to. But compared to ay butil ng bigas, ito siya. Yan. Comparing yung ating butil ng bigas sa ating bearing na world's smallest. Yan, ganyan lang siya kalaki. And kasi yung size niya is sa outer diameter, 1.5 mm lang. Inner diameter ay 0.5 mm. And yung thickness is 0.65. Material, stainless steel din. Yung typical bearing material natin. Features is, yun, title niyang world's smallest ball bearings. Performance, capable naman siya of more than 5,000 RPM. So, small but terrible and very rigid, matibay din siya. And uses, saan ba ito ginagamit? Bakit gumawa sila? Sa modern world, papunta na nga tayo sa nanotechnologies. Pero meron pa rin tayo mga micro machines. Robotics, yan. Marami diyang moving components na kailangan din ng bearings para maiwasan ng friction and di masira. So, medical devices din. Makikita rin sa medisina, sa medicine, sa larangan nun, sa field nun ay meron din mga gamit, equipments na ginagamit para sa mga maliliit na operations. And moving din siya, kaya kailangan din siya ng bearings. And dito, pumapasok ang world's smallest bearing. Next. Okay. Viscosity, sa ibang pagkakakilala dito is yung lapot. But here, it is the resistance to flow or the property which resists shearing of the lubricant. Okay. We have two types of viscosity. It is absolute viscosity, which is determined by direct measurement of shear resistance, and our kinematic viscosity. Ito yung absolute viscosity divided by our specific gravity ng ating material. So, units ng absolute viscosity in English is rein. 1 rein is equals to 1 pound second per square inch. And sa ating metric naman is 1 poise is equals to 1 rein second over centimeter square or 1 Pascal seconds. And sa kinematic viscosity naman ay 1 stroke is equals to 1 centimeter square per second. Yan ating unit analysis and conversion factors ng ating viscosity. Okay. Excuse. Formulas for bearings. So, typical formula natin is for sliding bearings. We have the diametral clearance and the radial clearance. So, parehas lang sila. Diametral clearance if diameter ang given or diameter ang pinapahanap na unit. And we have the radial if radius yung pinapahanap. So, diametral clearance is C sub D equals D minus smaller d, diameter of the journal. And our radial clearance denoted by C sub R is equals to radius ng ating bore ng bearing minus R radius ng ating journal or yung ating diametral clearance divided by 2. Yun yung derived formula ng radial clearance. So, ano ba yung radial clearance na yan? Again, we have our bearing, halimbawa. And we have our, let's define ano ba ang journal din. Journal is our shaft inside our bearing. Yun ang journal natin. So, kung titingnan natin dito sa side view, itong lahat ng nilalapatan ng ating journal, that's the diametral or radial clearance. Yan, itong space na itong bakanteng to, yan ang ating clearance. Unit loading or kilalang-kilala natin na stress ay force over cross-sectional area or P equals ating force or load over LD, length at diameter ng ating bearing. Eccentricity, denoted by small letter E, is equals to C sub D over 2 minus HO or yung ating film thickness or lubricant space or C sub R minus HO. Eccentricity naman is, imagine meron tayong lubrication sa ating clearance. See? may lubrication dito sa mga spaces na to. So, pag halimbawa umikot yung bearing or yung shaft and hindi siya pumapantay sa mismong center ng ating bearing, the distance or yung measurement ng needle point or center ng ating journal at center ng ating bearing, yun ang ating eccentricity. Okay? Next. Next. Okay, we have the bearing modulus. Bearing modulus is equals to our viscosity in reins multiplied by speed in RPS or rotation per second over unit loading in PSI. Okay. What is bearing modulus nga pala? It is a dimensionless number used for determining okay. It is a value para pag magdi-design tayo ng ating ball bearings. And mas ma-elaborate siya and madi-discuss sa libro ni Peirce. Yung ating black book. Yan. Sa likod nito, meron mga values ng ating bearing modulus when designing a ball bearing. Next, we have the frictional torque formula in bearing. It is denoted by T sub B equals F or radial load multiplied by our coefficient of friction multiplied by bearing diameter divided by 2. So, saan mahanap si coefficient of friction? Okay, kung babalik tayo dito sa ating previous slides, we have our eccentricity. Okay, we have our eccentricity formula. So, once na makuha natin ang ating eccentricity, ng ating ball bearing or roller bearing or journal bearings, rather, and we have a given value of L over D or ng ratio ng ating length over our diameter. Halimbawa, let's say for example, ang ating value ng LD is 1 and ang ating value ng eccentricity na nakuha na i-design natin sa ating journal bearing is 0.6. So, yun. Balik tayo dito. We have 1 and 0.6, di ba? For example lang, on page 597 sa libro ni Peirce, itong black book na to, we have our table 8020, dimensionless performance parameters for full journal bearing. Okay? So, doon makikita yung ating friction na ating value for minimum friction. And to gamit yun, makukuha natin or masosolve natin ang ating coefficient of friction. Okay? Of course, using Summerfield formula pa rin naman yun. And that's another topic. Then that's another topic for our next video. Okay. Next, Petrov's equation. Friction equation in frictional torque then. Okay. So, kanina meron tayong frictional torque. And ngayon, bakit meron din Petrov equation din for frictional torque din? Anong kaibahan ba niyan? So, frictional torque by definition, it is the torque caused by the frictional force that occurs when two objects in contact move. So, anong kaibahan yan? Meron tayong frictional coefficient of friction dito. May radial load, may diameter, and may over 2. May Petrov's equation, mas pinadami. Diba? Originally, Petrov's equation is used to determine the coefficient of friction natin. Okay. Yun yung ating Petrov's equation. Pero dito sa ating slide share, Petrov's equation is used in frictional torque to find the frictional torque. Okay, this equation gives the frictional torque due to viscous drag, and it can be expressed in terms of equal and coefficient of friction of the bearing. So meron siyang viscosity na if ever meron tayong lubricant sa ating bearings. Okay? Next, we have the heat dissipated in journal for bearings. Siyempre, umiikot yung ating bearing, umiikot yung ating journal sa loob ng bearing, sa, sa yung ating journal sa bearing. And kahit meron tayong lubricants, hindi pa rin maiwasan uminit ang ating equipment. So, kaya siya merong heat dissipated, which is H is equals to length ng ating bearing, heat dissipation coefficient, and the bearing diameter over 778. Okay? Okay. And ito, ball and roller bearing formula naman. Ito yung bearing capacity based on stresses for ball bearings naman. Which is denoted by F sub R is equals to K sub 1 times the number of ball bearings multiplied by R roller diameter square over 5. And yung ating bearing capacity based on stress for ball bearings naman, wait lang, parang parehas lang. Okay. So F sub R is equals to K sub 2 multiplied by number of balls or rollers natin multiplied by the diameter squared over 5 then. So we have the values for K sub 1 and K sub 2, which is 550 for unhardened steel, 700 for hardened carbon steel, 1,000 for hardened alloy steel on flat races, 1,500 for hardened carbon steel, 2,000 for hardened alloy steel on groove races. And for our K sub 2, 7,000 for hardened carbon steel, and 10,000 for hardened alloy steel naman. And next, I think that would be all. Thank you for listening. Again, this is uh, this is our presentation about bearings. And I